Hello everyone, I am Menzierah D. Mipanga, and I'm going to solve some problems regarding to the ways of expressing concentration, colligative properties of solution, and thermochemistry. From ways of expressing concentration, we have mass percent, mass per volume percent, and volume percent. From colligative properties of solution, we have boiling point elevation and freezing point depression. From thermochemistry, we have calorimetry. Here are the formulas of mass percent, mass per volume percent, and volume percent. Mass percent is equals to mass of component in solution over total mass of solution times 100. Mass per volume percent is equals to mass of component in solution over total volume of solution times 100. Volume percent is equals to volume of component in solution over total volume of solution times 100. Exercise 1. What is the mass percent of sodium hydroxide in a solution that is made by dissolving 8 grams of sodium hydroxide in 50 grams of water? Given 8 grams of sodium hydroxide and 50 grams of water. We are going to find the mass percent of sodium hydroxide in a solution using the formula of mass percent. Because we're going to find the mass percent of sodium hydroxide in a solution, the mass of component in solution would be the 8 grams of sodium hydroxide. The total mass of solution would be 8 grams of sodium hydroxide and 50 grams of water because that makes the entire solution. So, the mass percent of sodium hydroxide is equals to 8 grams of sodium hydroxide divided by 8 grams of sodium hydroxide plus 50 grams of water times 100. It will become 8 grams divided by 58 grams of sodium hydroxide times 100. The equal is 0.138 grams sodium hydroxide times 100. And the total answer is 13.8% of sodium hydroxide in a solution. Another exercise. Determine the mass per volume percent of a solution made by dissolving 175.2 grams of table sugar in water to make 275.5 milliliter of solution. Given, we have 175.2 grams of table sugar and 275.5 milliliter of solution. We are going to find the mass per volume percent of the problem. Mass per volume percent is equals to 175.2 grams of table sugar, which is the mass of component in solution, divided by 275.5 milliliter of solution times 100. By dividing the mass of component in solution over total volume of solution, we have 0.636 gram of table sugar times 100. So the final answer is 63.6% of table sugar. Here's the formula of boiling point elevation and freezing point depression. Small letter m is for molality. Delta T subscript P is for boiling point elevation. Delta T subscript F is for freezing point depression. Capital letter K subscript P is for boiling point elevation constant. Capital K subscript F is for freezing point depression constant. Boiling point elevation is equals to capital K subscript P times molality. Freezing point depression is equals to capital K subscript F times molality. Exercise 2. Automotive antifreeze consists of ethylene glycol, a non-volatile non-electrolyte. Calculate the boiling point and freezing point of a 25 mass percent solution of ethylene glycol in water. With the given, capital K subscript P is equals to 0.51 degrees Celsius per mole, and capital K subscript F is equals to 1.86 degrees Celsius per mole. Given 25 mass percent solution of ethylene glycol. Boiling point elevation constant is equals to 0.51 degrees Celsius per mole. Freezing point depression constant is equals to 1.86 degrees Celsius per mole. We are going to look for the molality, the boiling point elevation, and the freezing point depression. Let's assume the convenience that we have 100 grams of solution. Because the solution is 25 mass percent solution of ethylene glycol, the masses of ethylene glycol and water is 250 gram and 750 gram. Molality is equal to the mole of ethylene glycol divided by the mass of water. But before that, we are going to look for the mole of ethylene glycol and converting the 750 grams of water into kilogram. So 250 grams of ethylene glycol divided by 750 grams of water times 1 mole of ethylene glycol divided by 62.1 grams of ethylene glycol times 1000 grams of water divided by 1 kilogram of water. So the answer is 5.37 moles. Next is we're going to look for the boiling point elevation. Boiling point elevation is equals to 0.51 degrees Celsius per mole times 5.37 mole is equals to 2.7 degrees Celsius. But that doesn't end there. Boiling point elevation is equals to normal boiling point of solution plus boiling point elevation. Normal boiling point of solution, which is the water, is equals to 100 degrees Celsius plus the boiling point elevation of the ethylene glycol, which is 2.7 degrees Celsius. The total answer is 102.7 degrees Celsius. Freezing point depression is equals to 1.86 degrees Celsius per mole times 5.37 mole, which is equals to 10 degrees Celsius. Normal freezing point of solution, which is 0 degrees Celsius, is being minus to freezing point depression of ethylene glycol, which is the 10 degrees Celsius. The total freezing point depression of ethylene glycol is negative 10 degrees Celsius. Here's the formula of calorimetry. Q is for heat, capital C subscript S is for specific heat, M is for mass, and delta T is for change in temperature, which is equal to final temperature minus initial temperature. Exercise 3. How much heat is needed to warm 250 grams of water, about 1 cup, from 22 degrees Celsius, about room temperature, to near its boiling point 98 degrees Celsius? The specific heat of water is 4.18 joules per grams times degrees Celsius. Mass is equals to 250 grams. Final temperature is equals to 98 degrees Celsius. Initial temperature is equals to 22 degrees Celsius. Specific heat is equals to 4.18 joules per grams degrees Celsius. We're going to find the heat, but before that, we're going to calculate the change in temperature. Change in temperature is equals to the final temperature minus initial temperature. 98 degrees Celsius minus 22 degrees Celsius is equals to 76 degrees Celsius. Heat is equals to the specific heat, which is 4.18 joules per grams degrees Celsius, times mass, which is 250 grams, times change in temperature, which is 76 degrees Celsius. By multiplying the value and cancelling grams and degrees Celsius, we have 7.9 times 10 to the power of 4 joules.